Hello and welcome. I'm Aaron Redman with ExxonMobil and chair of this ongoing ECETOC Task Force. Thank you for joining us for this presentation today. We are excited to join the SETAC virtual experiment and join with you in this virtual session. We thank the organizers for working so quickly to make this happen. Today we'll discuss our work on the ECETOC Task Force bringing persistence assessments into the 21st century. Since the development of PBT assessments, there has been dramatic improvements in the experimental, numerical, and conceptual methods used to evaluate degradability of chemicals in the environment. You can see that there's a lot of interest in this topic from a wide variety of stakeholders listed here as co-authors. There are over 22 participants in this task force. It's our largest ever. Our challenge has been to summarize the advances and identify opportunities on how to put this new science into practice. I am grateful to my co-authors for their freely sharing of their expertise and support to this project, and also to the ECETOC Secretariat for their tireless work to keep us organized and on schedule. Persistence assessments fall within the formal PBT frameworks that have been developed at UN, EU, and at country levels. These often require the characterization of biodegradation rates in different compartments against some criteria. One of the challenges with this approach is that it ignores the reality of chemical fate behavior. For example, the transfer of chemicals between compartments, but also the importance of abiotic factors such as photolysis or burial. One of the other challenges with this approach is that the prescribed methods are more than 15 years old, and in most cases are based on the chemistry of legacy organic pollutants, which represent a very narrow range in chemistry. Therefore, application of these standard methods to other chemistry types can result in meaningless or misleading data. This is a particularly challenging situation because there are newer experimental and conceptual methods available. And further, the state of science continues to evolve. This recognition led to the organization of a joint workshop with ECHA, member states, CEFIC, and CONCAWE to establish the state of science and review of ongoing work in academic and industrial research groups. We will come back to this later in the presentation because this workshop is part of a larger strategy to highlight the availability of new methods and to promote the adoption of these new methods into regulation and guidance. For example, even back in 2003, ECETOC was publishing reports on the need for updated persistence assessment methods. And in 2020, we are having the same conversation, this presentation today. And further, ECETOC has formed this new task force to continue to advance the call for improved experimental methods and more consistent weight of evidence approaches to integrate different data types. The specific goals of this task force are to develop 2 opinion papers that outline the need for consistent application of weight of evidence, and a second paper on general recommendations and strategies to improve experimental methods. This work will be further discussed in another joint workshop later this year. The goal of this second workshop is more about the implementation of these findings into guidance, on how to put these recommendations into practice. This work will be further supported by the CEFIC LRI project ECO52 that will develop detailed guidance on how to implement these ideas. This initiative will be further supported by the eventual development of a persistence assessment tool as a mechanism to introduce consistency into evaluations. The objectives of the weight of evidence paper are to begin to adapt the OECD 2019 Weight of Evidence Principles for Application to Persistence Assessments. For example, the guiding hypothesis will be to develop and interpret data to characterize the degradability as an intrinsic property of a molecule. This work will also highlight, again, the importance of a multimedia approach, both conceptual and modeling approaches, to organize and interpret persistence data. Please refer to our poster for this specific paper, poster 3.17p.7. The second paper is a methods paper that will highlight methods that are used to measure absolute and relative degradation rates, but also to highlight strategies that can be used to read across between substances. Two key discussions include the influence of substrate on degradation, including sorption limitation or bioavailability, but also environmental factors, such as the abundance and diversity of microbes in and between compartments. Please refer to our poster on a specific paper at 3.17p.6. The next few slides are shown to illustrate the larger problem that we are trying to address. These data were compiled by Chris Hughes and others at CONCAWE and represent the degradation of phenanthrene, a 3-ring PAH, in different environmental compartments. There are multiple data for each compartment for this chemical shown here as half-life on a log scale. For example, photolysis rates are extremely fast. Half-lives on the order of minutes to hours. Half-lives in wastewater treatment or sewage treatment plants are also fast due to the elevated biomass in these systems. Half-lives in water, soil, and sediment have similar distributions, and the observed half-life can often span over an order of magnitude within each compartment. If our goal is to identify persistent substances, then we need methods that can explain or limit the variability that is observed within compartments. Is the variability controlled by biomass? Is it controlled by bioavailability processes? Or is it based on the structure of the molecule itself? The methods that are needed will be able to discriminate between environmental properties and help us to understand the true or intrinsic biodegradation potential. Because it is possible to design a test or find an environmental scenario where degradation is slow, but which is not necessarily reflective of the actual properties and intrinsic degradation properties of a molecule. The next challenge is to provide a basis for reading across between compartments. For example, if data were only available for water, do we have a basis for extrapolating to soil or sediment, such as on the basis of bioavailability or on biomass? Further, how should we integrate data for other processes such as photolysis and sewage treatment plants? These are substantial removal processes that are often ignored in current assessment schemes. A weight of evidence approach is required to help evaluate variability observed within a dataset. For example, in these sediment tests, the half-life can vary considerably and appear different from the data for other compartments, such as soil or sediment. However, evaluation of this studies show that these two upper points, the slower half-lives, are based on anaerobic conditions, and this lower point is based on a mainly aerobic condition. This aerobic data point is consistent with data for the other compartments in soil and water. This approach to look for consistency and remove data that are confounded by non-representative conditions is critical, such as these points which are anaerobic compared to the aerobic points that are found in soil and water and in this sediment test. because otherwise relying on worst case scenarios will lead to inconsistent and inaccurate evaluations. Finally, the body of data need to be evaluated in a multimedia context to explain which types of data are needed and to balance the relative importance of different physical and biological processes. This approach has been formalized as POV, or overall persistence. It is a convenient way to demonstrate the role of different fate processes and provide a convenient basis for comparing degradable molecules to non-degradable molecules, such as the use of reference compounds. For example, application of POV to phenanthrene using these data results in a short residence time of 3 days in this multimedia environment, which is remarkably different than classic persistent chemicals, which have POV or greater than 195 days. So, in summary, the task force is working to develop principles of weight of evidence and experimental design. But what we need are to work with regulators to understand how to implement these changes in a consistent manner. If not, we could be having this same conversation again in another 15 years, when the state of science will look even more different than it does today. We thank you for your attention, and we look forward to your input as we continue this process, and look forward to connecting with you through the networking breaks of this virtual meeting, but you can also find us on the ECETOC.org website here. Thank you, and have a good day.